Good morning. This is Mr. Reynolds, and we want to look at how we take how nitrogen is taken from the atmosphere and gets into living organisms like you. You need it to build proteins. Um, you need it to build. Now, there's proteins in all of your structures, and even when we say structures, even like, for example, like fluids. Okay, besides everything else, it's even tears. There's proteins in that also, and nitrogen is a critical component of that. That we don't get any of it when we're breathing this stuff in. We breathe in everything we take in. We're 79%, so we can say it's close to 80% of everything that we're inhaling is N2. Okay, um, everything. So the fixation part, nitrogen fixation, is how we take this atmospheric nitrogen and change it into some nitrates and some nitrites that we can utilize. These can get into organisms, into basically into certain types of plants. Animals eat those, and this is how it gets in the food chain. And then we get it in us. Even though we're breathing this in, we breathe that out also. We don't take it in there. We must get it in through our diet. So let's go on and look at the nitrogen. Nitrogen cycle is what we're going to look at here, and nitrogen fixation is part of it. So you can put a title on here: nitrogen cycle. Okay, showing how it's going around from the cow eating it to where it goes, through plants, back to the cow eating it. So that's the cycle part of it. What happens to nitrogen? We don't create or destroy it, but we can change it from one form to the other, and that's what's going on. So our first step is looking at this atmospheric nitrogen and how we get it into a usable form. That is the fixation word, okay? And it's pretty much done by nitrogen fixing bacteria in the roots of certain types of plants. These plants that do this are called legumes. Okay. Plants such as, I think, alfalfa. It's been a while since I've done them. I'm sure there's more on the list now, but legume alfalfa, um, different types of beans. Okay. They have nodules on the roots. Notice how it's pointing. These arrows are pointing to the roots on here. Okay, and there's some nodules on there, some little nodes. And in those nodes, some different types of bacteria are living in there. As the roots are extending down into the soil, bacteria are living in these nodes. And oh, they're not showing any of this, but just think for a minute. You know some of these critters, especially if you've gone fishing. How does this atmospheric nitrogen get down into the soil, down into the roots? Okay, we need some openings. What little critters crawl through the soil, and basically they eat the soil as they go, and they digest it and they push it out the other end. So if you go fishing, you're getting ready to go fishing, you stick a shovel down in some dirt, you turn it over, and you look for little holes in there. What made those holes? Yep, some worms. Okay, so put down worm holes, and that's not the thing in outer space stuff. Actually, holes that worms make as they're uh, going through the ground. So there's openings. Atmospheric nitrogen can come into that and get down into the bottom of the roots. Okay, and these bacteria change that. So these are called nitrogen fixing bacteria. As you see here, nitrogen fixing bacteria. I've got some slides of this scientific name of this bacteria that does that. Okay, cyanobacteria. These are types of kind of pre-bacteria, um, but let's go to the next clear slide and put some other things down on this. Okay, some things that you know about nitrogen already. Okay, because I made you do some of these. You know the chemical formula, what's present and how many of each. You know its structural formula, the arrangement of those atoms. Oh, and they are triple bonded to each other. And if we look at the Bohr model, as simple as it is, it's a great visual representation. Okay, so 7 protons, 7 neutrons. This one, 7 protons, 7 neutrons, On the first shell, 2 electrons. First shell, 2 electrons. My outer shell, my valence shell, is overlapping. And remember, this distance from the nucleus out to the second shell, we said first shell is about my arm's length, a big beach ball. Second shell is from my classroom out to Dixie Highway, or the other direction, my classroom out to the goalpost. Okay, that's still very, very close. So this is going to be a really strong bond between these. The shorter the bond length, the stronger that bond is, the lot more energy it has. Okay, so now we said there's triple bond, and this is showing 1. And we're going to put the other 2. There's 2 electrons for each bond. Okay, 1 from this atom, 1 from that one. So 2 electrons, 1 bond, 2 electrons, another bond, 2 electrons, another bond. Okay, so I've got triple bonded. It doesn't happen very often. So each atom thinks it's got 6 electrons, and a 7th one and an 8th one. A 7th one and an 8th one. Okay. So super strong bonds with some of the Bohr models, and like I said, this shows it really, really well. Okay, we had 2 other representations that I made you do before, and one was actually a Lewis structure, where we use the dots, but when we said when it's a compound, 2 or more atoms, they call it Lewis structures. Okay, so since it's triple bonded between it, okay, here's 1 bond, 1 electron from each atom, right? 1 from each atom. And then 2, probably fill in the s orbital, if you remember the electron configurations at all. Okay. The other form was the overlapping electron. We just call it overlapping orbitals. Okay. Overlapping orbitals. And one thing I didn't have a chance to teach you, which wasn't much further learning, an orbital is basically one little section on it, like we'll see here. So again, we got nitrogen 2. So we're going to line up overlapping orbitals. We're going to use the electron configurations and the 2 electrons on the first shell. If you want to look back at the Bohr models that you just did, okay. All right, there's 2 electrons on the first shell. That's my 1s2. On the second shell, I've got 5 electrons, a 2s2. That's filled. Then we go to the p's. Got to put 1 in each, right? Hund's rule. 2px1, py1, pz1. Got to have 1 in each before any in that type can be filled. And the other nitrogen is the same thing. 2s2, 2px1, py1, pz1. We're doing a little bit of review right now. Oh, and then you show, so like I said, this one gets to show exactly where those electrons are being shared. So here we go. We have electrons being shared in the 2px. We have electrons being shared in the 2py. We have electrons being shared in the 2pz. So these atoms think that they have, 2 electrons each. So they're filled. Okay. All right, looking at the slide again and taking some other notes on it. Notice that we have the like I said, nitrogen. It's critical. It's one of these top 4. Gotta have it. Okay, carbon, hydrogen, nitrogen, and oxygen. That was 96% of it. All of our all of our mass. Those 4, and phosphorus and sulfur. Okay, now it's 99%. Oh, and with us being vertebrates, we've got what element in there? In bone. That's right, calcium. Okay, so that's going to be close to 99.9% of everything that we are. And the rest of the things we call trace elements. That's review. Okay, things like iron, even though we have a lot of it, it seems like a lot. It's nothing like this. Okay. We're going to change this N2 back. Like I said, bacteria break it down into NO3s, the nitrates, which you know. Way to go. NO3, that was the structure that you did. And the other one was the nitrites, the NO2. Remember, nitrogen likes to bond 3 times. Okay, so NO3's nitrates, NO2's nitrites, which you know. those can be taken into, these can be taken into plants and used, okay? Well, these can be taken by animals and used, okay? And by other plants also. Remember, again, it was just these types of plants that had those nodules that could actually do the nitrogen fixing, okay? Because there's some bacteria that are living in those little nodes in the roots of those, okay? And here is one type right here. I need to take a good look at him, at that, since we have some of these slides in the microscope lab. This is what I wanted to show you, the NH3. Let's go to